Now, something you should already have done because you were responsible, all right, is you should have all of these points plotted. But if you don't, you better hurry up and make sure you have these points plotted accurately. We have E. We have F, -6, and a -4 right there. G is 5 and a -2. And last but not least, H is right here at a 10 and an 8. Now, what I expect everybody to do is have a nice, neat, precise drawing. This is very important. As you are building this quadrilateral, that's the first step. Draw a nice, neat quadrilateral. That's what you should already have done. So if you have that done, this will be even easier. The next thing we're going to do is we're going to build some right triangles to figure out the measurement of these sides. So the first side we're going to figure out is the distance from H to G. So what I want you to do right now is I want you to draw and make a right triangle, and I'm going to shade it in so hopefully you can visualize what I'm asking you to do. So right now, I want you to visualize this right triangle that I've drawn. And that's what you're doing on your paper right now. That's what you're doing right there on your paper. All right? We are going to find the distance from H all the way to G by using the Pythagorean theorem. Okay? So this distance right here is 1, 2, 3, 4, 5. So I'm going to label that 5. And this distance going all the way up, if you took the time to count them, that's 10. Now, you guys remember the Pythagorean theorem. If you ever have a right triangle, you guys should already know this, okay? So if you have a right triangle like this, we'll call this A. We'll call this B. We'll call this C. All right? We know that A squared plus B squared equals C squared. But the shortcut, here's the shortcut. C will always equal the square root of whatever A squared plus B squared is. So what is our A and B value? 5 and 10. So C equals the square root of 5 squared plus 10 squared, which is the square root of 25 plus 100, which is 125. Now, for those of you who are sticklers about simplifying radicals, we'll show you how to simplify a radical real quick. This breaks down to a 25 and a 5. This breaks down to a 5 and a 5. Since you've got a couple of them, this will simplify to 5 radical 5. But all of you have had Algebra 1, so you all know how to simplify radicals. All right, so basically, this distance from H to G, that distance is 5 radical 5. The unsimplified version is the square root of 125. So that's the distance from H to G. Now the next thing I'm going to do is I'm going to go right over here to F to E. I'm going to draw another right triangle. You're going to notice that these have the exact same dimensions. That's a 5 and that's a 10. So I'm not going to redo it. We've already done it, so I'm not going to do all the math over again. Just understand that this right triangle right here is the exact same as this right triangle, which means the distance from E to F without doing any work would be also what? 5 radical 5. Or the square root of 125. The exact same distance. The next thing we want to compare, I'm going to change colors a little bit. The next thing we want to compare is the distance from E to H. So you'll notice that this right triangle is slightly different. But you'll notice that the distance from E to H and from G to F, they form two right triangles that appear to be congruent. Okay? So right now I'm just going to color these in so you guys can see that these definitely appear to be congruent. We'll see if their dimensions are the same. What's the distance from right here to here? How many units? 2. They're 2. From here all the way to here, we're going from -1 to a +10. That's 11 units. So here we also have a 2 and we have an 11. So what would be the shortcut to find the distance from E to h, what am I going to do? I'm going to do the square root of what squared plus what squared?
A squared.
What is our a and our b?
2 and 11.
2 squared plus 11 squared. Interestingly enough, 2 squared is 4. 11 squared is 121. And those added together become what? 120. Come on, you stupid boy. 125. There we go. 125. Now, what does that simplify to? 5 radical 5. So what does that tell us about? They're all the same. So all of these sides are congruent. If they're all congruent, what does this have to be? It is equilateral. It's an equilateral quadrilateral. But man, if there was just a word to describe an equilateral quadrilateral, wrong. So right now, here's what I want you to write. I want you to write, this is definitely a rhombus. Now, just let me explain something real quick. A rhombus is a parallelogram. So you better write parallelogram. So this is a parallelogram that also happens to be a rhombus. So up here, I don't know if you guys can see this, but up here it says, we need to figure out which one of these is true. Is it a parallelogram? Is it a rhombus? Is it a rectangle? Or is it a square? It says list, keyword, all that apply. So what is the answer for this question? The answer is, it is a rhombus and is a parallelogram. Then when it says what? Explain your reasoning. What's the reasoning without having to use a whole bunch of words? You just showed me all the work, that all these sides are congruent because they're equal. And how did you prove it to me? You just didn't say they're equal. What did we use? We used the properties of right triangles to prove that sides were equal. That's what I want you guys to do on problem number 39. So the last one we're going to do right now is we're going to do problem number 41 together. So, Sean, give me an ordered pair for number 41. Give me an ordered pair. Ordered pair. -2, -1. Okay, right here. -2, -1. That is point E, I believe. Right? Nathan, give me another ordered pair for number 41. I have -2, -1. Give me another ordered pair. -4 what? 3. Right here. -4, 3. And what letter is that? F? Okay. All right, Houston, give me another problem. Another ordered pair. 1, 5. Right there. Is that G? Okay, and what's going to give me H? What's H? 3, 1. 3, 1. Right here. Here's 3, 1. I'm going to put H right there. So now I'm going to connect these nice and carefully. Okay, there we go. Now what I'm going to do is I'm going to make some right triangles to go with this so we can kind of test some lengths of sides. So we're going to go from G to H. There's your right triangle right there, which will match from F to E. And then we have from F to G and from H to E. So I'll color these in so you guys can see these right triangles. And once again, what am I using the right triangles for? I'm using them to find the distances between the 2 points. That's what I'm doing. I'm testing their distances. Alright, so right now, let's look at from G to H and from F to E. They're going to be, you probably realize these are going to be congruent to each other, okay? So this distance right here is a 2. This distance right here is a 4. So I'm going to do the square root of 2 squared plus 4 squared, which is the square root of 20, which simplified would be a 2 radical 5, but we don't have to do that. We'll do that later. So right now we have basically the square root of 20 is this distance. So these distances are equal to each other. Here we have a 2. 1, 2, 3, 4, 5. Here we have a 5. Here we have a 2 and a 5. So if I look at those distances, what am I going to do? The square root of 2 squared plus 5 squared. 4 plus 25 is 29. This is simplified. You can't simplify that anymore. So these distances are equal. So this one, opposite sides are congruent, but not all sides are congruent. So if just opposite sides are congruent, what can we call E, F, G, H? What can we call this quadrilateral?
Rectangle.
Nope. Parallelogram. Now, Alex, you said rectangle. What does it appear to look like?
A square.
Well, it does appear to look like a rectangle, doesn't it?
Yeah.
So let me explain something to you guys. This right here is not a rectangle because the slopes of these line segments, the slopes, are not perpendicular to each other. There is a test that you guys need to know. And I want you guys to write this in your journal right now. Perpendicular lines have slopes.
Are we getting this back?
Yes. Have slopes that are what's called negative reciprocals. You guys should already know this from Geometry A, but this right here is key. Perpendicular lines have slopes that are negative reciprocals. So here's some examples of negative reciprocals. If I have a 1 over 2 slope, the perpendicular slope would be negative 2 over 1. If I have 2 over 3, the perpendicular slope is negative 3 over 2. If I have a negative 4/3 slope, the slope that's perpendicular to that would be positive 3 over 4. You have to know these in order. This is a rectangle test. Like, can you test that it's a rectangle? Right now, we're going to look at 2 different slopes on our paper. Right now, let's look at our slopes. What is the slope of this green triangle? How much does it go up and how much does it go over? What's the slope right
It
there?
goes over 5 and it's up.
Up 2. So this slope, everybody, is 2 over 5. If I wanted to find a perpendicular slope to this, the perpendicular slope would be negative 5 over 2. Then I would know it would make what? It would make a right angle. All right. Now, what's this slope? How much does it go down and how much does it go over? It goes down 4. It's a negative slope. It goes down 4 and it goes over 2. Now that would reduce everybody to a negative 2 over 1. What would be the perpendicular slope for a negative 2 over 1? Positive 1 over 2. So these are really, 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 really close to being perpendicular, if you think about it. How close? If you look at a protractor and you see a right angle, look how close this is to being perpendicular. See how close it is right there? Very close. But guess what? It's a little bit off. If this was a 2 and a 4, if that was a 2 and a 4, then they would be perpendicular. And you would call it a rectangle, and you would also call it a square, because they were all the same size. So in summation, this is not a rectangle, it's simply a parallelogram because opposite sides are congruent. This is what you need to put into your journal next, right here. You need to put that with all different colors. Put that into your journal. Now, everybody, this is a Venn diagram. Let me explain to you how this Venn diagram works, okay? All of these names right here, all of these are quadrilaterals. They're types of quadrilaterals. So, every single parallelogram is a quadrilateral. Every single rhombus is inside which circle? A rhombus is inside the circle of parallelogram. So, every rhombus is a parallelogram. Every single rectangle is a parallelogram. Every single square, guess what? Every square is a rhombus. Every square is a rectangle. And every square is also a parallelogram. So how does this work? Right? Are all rectangles squares? No. A rectangle is a square if it shares the same properties as a rhombus. You guys see where these are intersecting? What does this mean right here? This means that a square shares all the properties of a rhombus, and it shares all the properties of a rectangle, and it shares all the properties of a parallelogram. So I'm going to zoom out. Is a parallelogram a square? Now you have three choices. One of them is, yes, that always happens. One of them is, sometimes. And sometimes, no way, this is never true. So your answers are either always, sometimes, or never. Is a parallelogram a square? Sometimes. Very good. So we're going to write this right here, everybody. The answer for number 42 is, this is sometimes true. Now what if I reverse the word? What if I said a square is a parallelogram? Is a square a parallelogram? Always. So that would be an always true. So here we go. A square is a rhombus. Is a square a rhombus?
Sometimes.
Wrong.
Oh, always.
Always.
Dang.
Now, how about this? If I would have said, Jake, if I would have said, is a rhombus a square? You would say a rhombus is sometimes a square. A rhombus is a square only if it has the same also properties of a rectangle. So where these intersect, remember, where these intersect, what is this part right here stating? This is stating that it shares all the properties of a rhombus, a rectangle, and all the properties of a parallelogram. Your job is to finish these statements. Remember, what are the answers? Not true or false. The answers are always, sometimes, or never. Good luck.